Hey, everybody. Great to be here. Chris Neidl with the OpenAir Collective. This is our weekly stream planning chat session for the Epiphyte project, open source direct air capture. And we are a group of 4 right now. Might have a couple other people join. One thing I've just discovered in the last day is that our UT team has rejuggled their class schedules a bit. So this is no longer optimal for them. So we'll have to see if there's a way to come up with an alternate time. I'll check in with them. The good news is they're as eager as ever to get started. And we're having our first in-person meetup as a team on September 12th, which is a couple weeks off. But hopefully in the meantime, they can join these calls. How's everybody doing?
Well,
excellent. Great. I know you got to jump early, Seth. Well, I went down a bit of a rabbit hole this week and did some research on some of the stuff that we discussed last week, and I shared some stuff on the Discord about a possible change we could make that I think we've discussed before, but it might solve the problem that we have of the heat air transfer in the closed chamber during desorption. And I'll just share a couple of images. So we had gotten to this, this was our, let me move this back here. This was our basic idea of how to fit things together. Let me let my dog out. Oh. And so the problem we had was, okay, well, we get all these parts in here and we can, you just got to figure out with the heat, once we close it, how do we move the air around or the heat around? And there was concerns about, if you have a fan in there, does it add to the sort of the pressure? And then just the basic idea I had was to go ahead and turn it upside down vertically. And would that have sort of a chimney effect where the heat would naturally just sort of, obviously not as much with forced air from the fan, but would it do the trick to then go through the cells of the monolith? If we kind of make it really snug in there, there won't be air going, around the sides of it, but it would all flow through those cells. So let me just pause on there. Ling, you gave sort of a favorable tentative thumbs up, I think, to the general premise, but curious if folks want to talk about their thoughts on that.
So which way would the air be flowing during the adsorption phase?
It would go from the top. The fan would then pull it through the bottom.
And then during the desorption phase, the fan is off, but then the heater is heating the air and the air floats up?
That's the idea. Do we think that would be enough? How do we find out if just the natural rising of heat is enough? I mean, I don't know. I don't know what I'm talking about. But what do you guys think? Do you think that would be sufficient? I mean, it's going to go up, and that's where we want to go. So we could put the heater below and then the monolith right above.
There are probably thousands of people that can calculate it on the back of an envelope, but yeah. I don't know.
Yeah, it'll be enough to heat up the chamber, generally speaking. I think the concern is more that will the air be well mixed? And we don't know that unless we do spot checks with sensors. So there comes challenges to every problem, right? To every solution.
Yeah. I also kind of like the idea of just this chimney idea, just from a sort of metaphor perspective. So it kind of looks like a chimney. It's like a reverse chimney, Yeah. That's a minor, sort of cherry on top if it works, but that's kind of cool. When you talk about air mixing, how relevant is air mixing if we don't have a lot of space in the chamber and it's sort of closed and there's a gap and there's kind of only one direction for the heat to go in?
It's pretty relevant because if we don't have the air mix, then what we usually do with temperature control is a feedback loop, right? And we need the air to be well mixed for that reason. So it would be wise to give a bit more room, maybe at the bottom. I don't know. But if, let's say that like it's not well mixed and you have a sensor somewhere, and if it's in the hot area, then parts of your monolith will not get hot enough. If it's
Yeah.
in the cold area, then you will waste too much energy. So it's quite important for something like this.
And the CO2 sensors are very temperature dependent, so we could get bad.
Do we want to though put in terms of where the sensors go though? It's probably on the damper, right? The first inlet one would be on the outside of where the damper closes, and then the out one would probably be on the damper, but on the inside of where the thing closes, right? Because we want to be able to measure how much CO2 is accumulated in there. Just wonder if we can get that far away enough where it won't be super, super hot. I don't know. That's a good question.
I mean, my concern is we're going to end up with, either hot spots or just an overall temperature gradient without remixing it. We've got a hot spot at the bottom where the heater is. And we've got presumably a hot spot at the top where all the air is collecting. What does that gradient look like between these points? It may be very minor. It may be pretty big.
Yeah. All right. Okay. But you don't think that's disqualifying of the general idea, right? Of trying to remove that second fan, which had all sorts of implications in terms of like, how do we get it in there? Can it be, what heat can it be exposed to? What's static pressure, WC or whatever they call it, that would be created within the chamber with a fan. So let's just tentatively say we'll pursue a vertical option, unless math and some experimentation tells us that we should go back to horizontal.
Well, the real question is also, can we really live without the second fan? So I would recommend to be designed in such a way that we may try it without the second fan, but have it flexible enough physically so it won't rule out adding one if we decide we need it.
Yeah. Before I went down this whole route, here, let me go back to us. I was looking at other things. Could you have like a buffer chamber in a way that was sort of on the end of it, so that you could have the damper is right on the tube, and then you are blowing the fan, but you can occasionally open the damper up to allow some of the air to go into this other chamber. And there's vents that are available for HVAC like that, like these sealed square boxes that would kind of take some of the pressure off, but would keep the air enclosed in that space so that we don't lose the CO2. That was another thought, because I don't think we didn't have any real ideas. There was a couple things I think that were floated around, like how do we reduce pressure without opening it up and losing the CO2, right? So I don't know. I also looked at some of the static pressure and water column ratings. I mean, again, I don't know what our requirements are for that, but are there certain kinds of fans that aren't going to malfunction in a high pressure environment and can keep, turning? Anyway, I'm speculating too much here. More for your guys' consideration to correct me.
Pressure is a concern for the sensors as well.
Yeah.
Both temperature and pressure are going to affect their operation.
Yeah. Was I right though, Seth, in terms of where we would put the sensors on a unit like this, whether it's horizontal or vertical? But they go in the damper, right?
Yeah, I would think so. Or, I mean, they could go where in the main cylinder, but not touching the model.
Yeah. You know what the heat tolerance is for those, Seth? So if we put it like on the top of the model. Good.
I mean, most of the sensors that I've worked with are they're rated for 40C, and then you can get them where they're a little ruggedized to go up higher. I mean, these sensors obviously are going to have to go higher than that. I don't remember the sensors we used in the first version, what they were rated for.
Let me write that down as something to ask the manufacturer.
Well, we'll look it up real quick.
Okay, cool. All right, so let's put that, a pin in that one for a second. The other thing that I was thinking, this issue of like putting too much stuff in the way of the airflow, and I had shared this image on the Discord, and you made a good suggestion, which I'll tell you about in a second. But if we had some kind of duct on the bottom, like a split duct, either a T or a Y or something called a way fitting, that kind of could create it where you have the damper on one of them, and then you have a sealed, the heat source is so you could have a situation where you open up the damper, and the air just flows directly through the channel, and you could use something, more like this, that is more, the right angle. I think that was your concern, right, Ling? That if you have it in like a 90 degree or 45-degree angle, 90-degree angle, then that might just be an indirect sort of route that the air has to take. It would be inefficient. But if you had something that was more downward.
The route that the vacuum takes doesn't really matter. Because the vacuum will be slower. I think the route that the fan takes will matter the most. Actually, the fan is pulling, so I'm not entirely sure if I'm right either.
Yeah, I'm wondering if a fan like that with something like this, if it's really going to get slowed down too much, if it just is a little bent, or even if it is at a 90-degree angle. But you guys
now that I'm thinking about it, since the fan is on the other end, it might not even matter. Maybe we do want the turbulence that's introduced.
Yeah. You have any thoughts on that, David? I mean, it'd probably be good enough if we had something like this, and the fan was pulling it up. I don't think it would get too slowed down by there being a bend in the road.
By the way, I was just looking at the spec sheet for the CO2 sensor, the SCD41.
Yeah.
And under absolute maximum ratings, it says operating temperature from -10 to +60 C, and beyond that range, it can be damaged.
Okay.
Oh, that's interesting, because I was just looking at the data sheet, and it says its measurement range is -20 C to 85 C.
Measurement for which? For CO2 or?
Yeah, under I'm looking at the data sheet under sensor performance.
Yes.
And the second box, 1.2 temperature, measurement range -20 to 85.
I have a different version, I guess.
Is that for the newest one, David? The one that we replaced it with?
Yes.
No, the older one, the one we used. We're talking about the one we used in the first Epiphyte.
Okay.
Oh, I'm looking at the one we chose for the new one, the STC31.
Oh, okay. Sorry. No, we were talking about the old one. Okay.
So that says 85 C, which is cutting it a little close, but that's what it said, Seth?
Yes.
Yeah.
I also, better than 65.
When we said 80 C, are we still thinking in terms of the zeolite? I did a little bit of research on the PEI, and I think that requires a little bit of a higher temp, like closer to 100. And I wonder what would be there, Seth? Would it be the hardware part of it, or that little probe? I wonder if there's like heavier, because that's the only part that sticks into the heated area, right? The other stuff's on the outside, right? So I wonder if there's some way of like getting a more heavy duty sort of head for the probe. Yeah. That's the hard part. Looking at these other things too is like, how do you get one of these heating elements that gets hot enough that won't then damage the other parts? You know, and kind of like when I looked at these guys, I found a couple of options. So these are the ones we looked at before. It was this guy, this guy, this guy, and I found another one too, which is this one, which I think has a higher heat threshold. Output temperatures up to 50 degrees C. That's not even good enough, you know? So I did look at a couple of other things. This thing's pretty interesting. It's called a nickel chrome flange duct heater, and it goes up to 600 degrees F. It's a convective heat that comes out of the top. And this is like a 4-inch kind of flange on the bottom. I think this is like a 2-inch. Sorry, Link. You could have a situation where you put the tube that fits on top of it, and then that little J box there is sort of the bottom. You just have to seal the bottom up better, and that definitely gets way hotter. It's about $200. And then I found these dudes, which are pretty interesting, which are actually ceramic honeycomb heaters, and they get really hot and very fast. And apparently, they're really efficient, and they actually come in these 6-inch discs. So you can sort of tuck it in the bottom. So I reached out to get pricing on it, but that looked kind of interesting to me as well. You see what I meant with this one, though? I thought that could be kind of cool. Is you just put the tube on top of it. The hot part, which is on top, is just inserted by a little distance, but you just have to seal it up on the bottom.
Chris, can you post the links to all of these things in the
Yeah.
Discord, maybe?
Yeah, I got it.
We can't just look at this page that it has no information.
Yep. Just to from what I have so far. So comment right now. That's one for the one that I'm looking at right now. I just put it in the comments. And then the spec sheet for it, I'm also putting in right below it. If you want to take a look at that, we can even look at the we could look at the spec sheet together. One second here. I think this is it here. Entire screen. All right. Can you guys see that?
Mm-hmm.
Yeah, this is it. It's only 4 inches wide. I don't know. Look, heat interest. It looks like you could stick it in to something. But I put the link. So all right, let me get back to you guys. Ooh, where is it? Let me see. Something like that, you could have like a you could have like this kind of thing. I was thinking, wait 1 second. Where's that image? Yeah. So if you had it like this, it could be kind of interesting to if you had the airflow goes completely vertical, and then you have this other duct that you would insert something like that device into on the bottom. So it's out of the way. It doesn't get in the way of the air pulled out of it, but it fits nicely and applies heat right below the collar. So those are my ideas. Again, just trying to move it forward. I sent out some emails to the supplier to find out more about cost for some of the ones that I don't know. So I don't know how we test it or who we ask about whether. I guess the good thing would be to talk to the manufacturer and say, "Hey, this is what I'm using. Would it be useful?"
I think we need to think about how to mount it, because okay, like every time we're looking at a new part, we have to incorporate it into the assembly. We can't, like, it may be a good idea, but it's always a balance incorporating each part. So it's really hard to decide whether this is the right thing to do if we haven't decided on what like the final direction that we're going in. But like, I think we have some kind of direction right now. But like, I don't know if this is clear, but we're all making educated guesses on what might work the best, right? Like, we don't know exactly what will work best. So yeah, you know what? I don't really know what will work best. So like, the more information we have, the better. So if you have like heating parts, it'd be good if you can post that on Discord. That way other people can look at it too, and they have ideas on how to mount them. The particular problem with this particular one is that it's very small. The diameter is very small. It's only 2 inches. If your monolith is big, let's say like 8 or 12 inches or even larger, then we have to find a way to mix the air. So like whatever you suggest, they may all be good ways to heat or mix air or whatever. We just have to put it together, and that's like where the engineering comes in.
Yeah.
So you know, like, it's, for me, it's not instant to come up with a solution for how to incorporate it, even if I think it's maybe a great way to heat.
Yeah. I mean, I think one thing would be is like if we settle with educated guesses on a combination of parts, and then have that as its own little video or presentation, and if we can share it with a broader world about where do you see problems for this possibly arising, and then we can also get some additional information from the suppliers. I have no idea what these things are used for that I just showed. It's something about, it gave a couple of use cases, but if I explained what we want to use the meter for, do you think it would work? Then, you know, they might be able to answer, but I think we need more input, I guess, on that.
I would suggest that we keep it within the team, and we can take suggestions in these in these sessions. But when people are chiming in with suggestions left and right, it can paralyze us in the path, and we keep like sitting at this point. The students are trying to get started, so if we're gonna go with this path, I'm fine with it. I think it would be good to re-include them in the conversation, and then if we all think it's a valid way to go, we just go with it. If we keep like thinking about, oh, what might be better, next week, we're gonna get paralyzed, and we just have to choose a path right now.
Yeah, so I'm trying to put forward a path.
Yeah, it's fine. I just like can't respond instantly. You know, like I need a week or two, and if we change our path next week, then I don't know the effort that I put in.
Okay. Well, let me run it by the UT guys. You know, they're mechanical engineers and electrical engineers and chemists and stuff, so they know a lot more than me.
Yes, but we should all discuss together in this call, like when we find a new time, because they may agree to some stuff, but there's, I don't know how experienced they are, but we, like, Seth and David and I have decades of experience at this point of engineering experience, and we should all give feedback to each other. So if like if they say like it looks good, and they suggest something specific, then it'll be good to have our eyes on it. And then when we suggest things, it would also be good to have their eyes on it because they're the ones who will be touching it. But we can't give feedback separately and decide, oh, we're gonna go this way, because someone will always have the last word on. There's a way. I think we should do it this way. It might be easier or cheaper, and then when that change is made, there may be something that may be overlooked.
Yeah.
So I think it's more important to get when to meet together to get all the students to come to these sessions again.
Yeah, definitely. And as I explained at the beginning of the call, it's not entirely surprising that at the beginning of a semester they had some class changes.
Yeah, we forgot. It's okay.
Yeah. So we'll come up with another time where they can be involved. But yeah, I agree. We just kind of have to. I just before we order any parts again is just like, is there looking at some of these options here, which are not randomly suggested. They're like, is it hot
Right.
enough? Is it the right fit? Can it sustain the right temperatures? And so I've been putting in a lot of time just trying to explore some options to present before you guys. So it just requires some thinking, I guess.
Yeah, it's good. It's good. Like I appreciate you posting these in the chat here, but I think it will also just be good to post it on Epiphyte because when we end this chat, it's hard to dig up those links. And then if I get some time or David and Seth, if we have some time to think about this, then we can come up with solutions because we can't decide on the path and then pick the parts that go into it. If we do that, those parts are going to be too niche for us to try to fit into. Like a lot of times it's a square peg into a round hole. So we have to design with everything in mind. We got to pick parts and then say, what is the best option with the knowledge that we have in hand? So it's fine that you have all these ideas. I think they're great. Like the more the better. But we got to pick a path. So we can't pick a path and then choose the parts. We got to do them all at once. And with all the options of all the heating options together, we can say, oh, I think it'll be best to use like this heating method or maybe like two together. What else do we need? And then we engineer the whole assembly that way. And we'll try to use the existing parts, but we may not have to. We're just doing the best with what we have.
Are folks going to be able to do that though? That's the only kind of question I guess I would ask sort of bluntly is the people who come up with the ideas and think about the thing, that's what causes the progress, I guess. And I am the least qualified person to be doing it, but I feel like I'm just sort of jumping in to do it so that we can start to get to a direction of a design. The things that you asked for links for, most of them are already on the Epiphyte. I just added another one or the Epiphyte channel. So
yeah.
So I do have a group of very enthusiastic students, one of whom is a PhD. So they probably are pretty capable, and many of them actually already built a small DAC unit last year. So I think it'll be really important to get the guys involved because they seem highly motivated to try to tinker with this stuff and figure it out. So we'll keep putting stuff on the Epiphyte channel on the Discord, and looking forward to any kind of feedback.
So when you say like, are folks gonna be able to come up with design ideas? I don't remember what you said. Sorry. Do you mean the UT students?
Anybody who steps up to do that thing, I guess, is really sort of the mode that we're in right now.
Yeah, they're free to come up with new parts. They're free to come up with ideas with existing parts, whatever. But we can only build one version. We can't just keep switching. So if people like a certain version, they can build it themselves too. But we gotta pick something to move forward with.
100% agree, and that's exactly what I'm attempting to do here. So, and they're sharing it back with you guys to see if it gets us closer to something we feel confident enough that we can make an order. So, So let's do that. All right. See you later, Seth. You had a meeting.
Oh
at
yeah, I forgot about
30. All right. So I have put, I think, most of this stuff. It's not. I wonder if it'd be even better to have some of the things on a Google sheet. Not that there's like so much velocity on that Epiphyte channel that links are hard to find, but I could try to put them all in a more organized way on a Google sheet.
Oh yeah, that's probably good. A Google sheet where there are heating, like maybe heating or housing options.
Yeah.
That would be a good idea.
So like a brainstorming sheet where we put all our ideas and then add comments on other people's.
Mm.
That'd be good.
Yeah, we could do that. And then, but I think more importantly is then if the question is, will this piece fit with this piece, given how hot this thing can get, or, like it's the more than the sum of its parts, you know what I mean? How do they fit together? So it's one thing to go and look for things that might solve the problem, but you have to think about them holistically in terms of how they would all fit together in terms of sizing and all the other variables. So like just hearing about everything, if that's like a maximum 85 degrees C temp, that might be right on the borderline we would be able to use without damaging the equipment over time, so just all the dynamics between the parts, I guess, requires thinking through. So
Yeah. I think that's a really good idea. We should start a Google sheet.
yeah,
I can't keep track of all the information.
yeah, I think also like between, I don't know, now and in our next meeting, I wonder if we could, if I show that Google sheet, if we could all take a look at it and try to think about it from a sample point of view,
Everyone should pitch in filling it out also, not just you, Chris. And yeah, like I think it'll be really helpful, like gathering it in one place so we can think about. A lot of times we have like when we create any kind of engineered piece of device, we have constraints, and then we have what we can change. And I think when we have this sheet together, we can write up more of what is fixed and like what are our target specifications. For example, like it has to go up to a certain temperature.
yeah,
Blah, blah,
exactly.
blah. I cannot go past a certain temperature. Blah blah blah. Like I'm not entirely sure what all those are, because I'm not that familiar with the sorbent, but I'm sure that everyone can pitch in writing this, because currently I think the information is so scattered that this is a good starting point.
Yeah. Okay, cool. Well, why don't I at least create a format for that, and then I'll share it with you guys, and we can add to it. So I'll create the skeleton, put the meat,
Yeah.
and then I'll send out our next meeting. I'll loop in the 3UT guys and see, when would be good for them. David, in general, for you, is during the day always sort of optimal, or is it actually better for you to be a little bit later, or what's best?
No, during the day is better
Okay.
for me.
All right. Let's figure out a way to land on the time that is best for most of us. I think it would be cool after the 12th or the 12th on. My plan is to sort of meet with them at their lab, so we might be able to set it up. So from now on, we're kind of.
Oh, like you're not sure for until then.
What do you mean?
Oh, like can we do a when to meet for just next week, or
Yeah.
do you want to hold off?
If we can't settle it by then, we'll hold on to this call for the next one. But as soon as possible,
Okay.
potentially next week, another time.
Yeah, I guess it's kind of disruptive for them to meet on an off week where there's no schedule. So
Yeah. So let me talk to them. I text them.
yeah. If I don't know when their school starts, but if they're free next week, they could probably meet at a random time. If it's too chaotic for them, it's fine if they want to skip. Yeah, I think I don't remember who it was, Charles or someone else, who said it would be good to have something, an idea ready by the time school starts, like second week of September or something. But I'm not sure if we can get that going, but we'll try. We'll try to. I think the spreadsheet will help a lot.
Yep, definitely. All right, cool. Let me work on that. In that, then we can jump off now. I think I know that that we did have some other things going on. So Will was starting to play around with he has a monolith, actually a small one at the lab, and some actual PI just sort of lying around. So he was going to try
that's
to
nice.
do that. And they have this amazing equipment at the lab there where with some kind of tool, they're able to measure very precisely of like what the carbon intake. It's like one of the most advanced labs in the country, he thought, among universities. So he's able to test a very small monolith with PEI with what he already has. And then our Abina had also shared, who's in the chat right now. She was exploring some potential alternative materials that we could find. She found something called PPS or polyphenylene sulfide, which
I'll look into that.
Yeah, which can withstand up to 218 C. So that would be good.
Yeah, I know very little about these things. I gotta look them up. But
yeah,
it's been very hectic lately at work.
Yeah, you can ping her on the Discord channel. She's in there.
Okay.
So she's looking into it. All right, cool. Then, guys, enjoy the rest of your week. Enjoy the weekend, and hopefully we will find a time between now and our next time to talk. Otherwise,
hey Chris, when are you arriving in Philly?
I'm going to get there either. I do crazy things where I sleep on floors of airports and stuff like that. So we'll see. I might get in very early in the morning on the 18th and go right to UPenn. This is for a UPenn meeting, or very late at night on the 17th, and then flying out that same evening, 18th. So, but yeah, it'll be fun. Did you hear anything back from them yet? I can follow up again with Peter. I had emailed him with you copied, but I'll get you.
No,
yeah,
nothing yet. You should stay longer and see some of the sites.
I love Philly, but my issue is just with family stuff. There's so many things going on with my life that I can't really take long trips, particularly since I have one to San Francisco in October, and I'm going to do Climate Week for a day or two in New York. So I got to be conscious of that. But we can at least get a dinner in, David. Why don't we plan to do that? So that'd be great. All right, dudes. See you later, and I'll work on that spreadsheet.
Okay, Chris, do you have a second?
I only have let me stop.
5 minutes is okay.
Wait, I'll stop the stream.